Hi students. Oh, I hope you are doing well. Okay. So again we are coming with a new concept today from the real numbers. The topic is before going to this kind of sum, like we are going to discuss one theorem. The topic basically is we have to prove the given number. That is, for example, here we have taken root 2 as irrational. And as you might be knowing the, the numbers, irrational numbers. What are irrational numbers? A number which cannot be written in P by Q form is an irrational number. Correct. So we already discussed those kind of, expansions and introductions in the previous sessions. So today we are going to prove that the given, this is, as we know, this is irrational number. And we discussed also, root 2 cannot be written in P by Q form. That is the reason it is an irrational number. So, but how to prove it? How can you prove that root 2 is irrational? And this sum is also important sum, and this is expected for your examination and for 3 marks. 2 to 3 marks, definitely they will ask this kind of sum. Okay, very, very important sum. Yeah, anyway, before going to that, let me discuss this theorem. Proof is not required anyway. I'll just explain the statement clearly. Okay, so because this theorem, okay, we are going to use in the proof of the the proof of the proving irrational number. In that we are going to use this theorem. So that's the reason I'm explaining you. Yeah. Anyway, just let me read the theorem statement. Let P be any prime number. If P divides A square, then P divides A, where A is a positive integer. See, what basically it says is any prime number you take, any number, for example, like any number, it may be prime number or any number. Let me taken P as a prime number here and A as any positive integer. Correct. So let me take any positive integer. Positive integer, let me take 4. Let me go with the smaller one so that you can easily understand. So 4 is a positive integer, correct? So now this 4, let me take 16. It will be easy to make you understand. 16. 16 is divisible by 4, correct? Understood? 16 is divisible by 4. Okay? If 16 is divisible by 4, even this, let A is equal to 4. I am taking A as 4. Correct? Or let me take it as 2. Okay? Fine. Let me take A as 4 itself. So 16 is divisible by 4. Correct? It means 4 4s are 16. Correct? My question is, if 16 is divisible by 4, 16 is also divisible by 16, no? Correct? Divisible by square, correct? It means if this 16 is divisible by 16, that is 16 is also divisible by 4. Okay, let me take one more example. 4 is divisible by, or let me take perfect square. Okay, 4 only you take. 4 is divisible by 4, correct? And if 4 is divisible by 4, 4 is also divisible by 2, correct? Understood? If 4 is divisible by 4, 4 will also be divisible by 2. Because here if you consider 16 is divisible by 4. Similarly, 16 is also divisible by 2. Why? Because this can be written as 2 squares. Understood? Or this root 4 is 2. Understood? And also this 4 is a multiple of 2. 2 into 2 you can write 4. Correct? Any number divisible by one number and the same number is divisible by its multiples also. It is very simple thing, basic thing. For example, 9 is, okay, let me write here. 9 is divisible by 3. Correct? 9 is divisible by 3. So definitely 9 is divisible by 9. Correct? 9 is divisible by 3, then definitely 9 is also divisible by 9. That means if you take this as one number p, if p is, let me just erase it. If p is divisible by a, correct? If p is divisible by a, that p same number is divisible by its square also. Remember, if p is divisible by a, p is also divisible by a square. It means, or you can take in vice versa. P is divisible by a square, then p is divisible by a also. Okay, I'll just let me consider p as 9 and a as 3. Okay, understood? So p is 9, correct? 9 is divisible by a square, correct? If this 9 is a, because a I taken as 3, correct? A I taken as 3, p I taken as 9. So my explanation is, if p is divisible by a square, it means if 9 is divisible by a square means what? 3 square, 9. So if 9 is divisible by 9, and if 9, then 9 is also divisible by 3, because 9 is a multiple of 3. Okay, it means any number divisible by that number, the same number is also divisible by its multiples. Okay, let me give one more example. 64 is there, correct? 64 is divisible by 8, correct? 64 is divisible by 8. I hope everybody knows. 8 is 64, correct? So tell me, what are the multiples of 8? It means 8 multiples are 2, 4, correct? 6, 64 multiples, sorry. Multiples of 64. 2, it is divisible by 64. 4, 4 ones are 4, 4 16, the 4 16 that will go. 6, I think it will not divisible by 6, but it is divisible by 2, 4, correct? Understood? We can take 2, 4 and lot many 8. You'll get 16. So if 64 is divisible by 8, multiples I taken 2 and 4, you can take how many you want. So 64 is also divisible by the multiple of 8, correct? I'm just taking the multiples of it. Leave about 16 multiples. Take 8 multiples, which are 2 and 4, correct? Multiples of 8 are 2 and 4. So 64 is divisible by 8. Similarly, that 64 is also divisible by the multiples of 8. What are those? 2, 4, even 16. So if a number, similarly, if you go in general way, if p divides a square, even p divides a also, correct? That's why 64 is divisible by 8. It means it is divisible by its squares also, or its multiples also. Very simple. Okay. If I just taken one example to make you understand. Any number is divisible by one number. It is the same number is also divisible by the multiples of that number. Fine. 9 is divisible by 9. Obviously, everybody knows 9 is divisible by 9. And if 9 is divisible by 9, 9 is also divisible by 3, because 3 is the multiple of 9. Correct? If 9 is divisible by 9, the same 9 is also divisible by its multiple, which is 3. So in generally what we can say, if p is divisible by a square, p is also divisible by a. Correct? P is divisible by a square. Here we have taken square. It may be anything. For example, I taken 3 square. So p is divisible by 3 square. Then it is not divisible by 3. Correct? For example, p is divisible by p is divisible by 2 square. Then p is divisible by 2 or not? Yes. If p is divisible by 2 square, definitely that p is divisible by 2 also. Similarly, you change the 2 with 4. If p is divisible by 4 square, that p is not divisible by 4? Yes, p is exactly divisible by 4. If p is divisible by 4 square, similarly, p is divisible by 4. You can take any number. You can take 5. P is divisible by 5. Then p is divisible by, p is divisible by 5 square. Then p is divisible by 5 also. If you take p is divisible by 6 square, then p is divisible by 6 also. In general, what we can say, if p divides a square, it's just like a simple, like divisible or same thing. If P divides a square, it means a square is like divided by P, correct? Then P divides A also. If 4 square divides P, correct, or P is getting divided by 4 square, then definitely 4 is divisible by P. It's very simple. That's all. Okay. So here you can take in the other way, or you can understand. That's all. See, any number you take, it's very simple. If any number, I taken A, I can take P, you can take any number. Any number, as I told you, if for example, 4 divides 2 square, then 4 is divisible by 2. You just leave about the number here. You can take any number. 64 I taken, or 64 divides, or 64 divisible by 8, 8 square, correct? 64 is divisible by 8 square, correct? So, which is not divisible by 8, definitely 64 is divisible by 8. Okay, like that. Any number, it is correct. You can take any number. This is just an example I have given. So now, let me explain the actual sum what we have to do. That is, prove that root 2 is irrational. And all of you know that like irrational number in the sense which cannot be written in the P by Q form. So that is the reason what I'll assume. See here there will be a very important thing you should know. We are assuming it in contrary basis. Contrary basis in the sense I'll just explain you. Okay, for example, any student is there. For example, Rama is a good boy. Okay, Rama is a good boy. We will prove that, we will assume that Rama is not a good boy. Okay, and we are not able to prove that he is not a good boy. Then what he is? Bad boy. Sorry, yeah. Okay, I'll just, I don't know whether you understood or not. I'll just explain once again. Rama is a good boy. Okay, I'm assuming that Rama is a bad boy. So let me go in this way. Rama is a good boy. I'm assuming that, first I'm assuming, my assumption is Rama is a bad boy. Okay, and I did some proof and everything, and at last I'm not able to prove that Rama is a bad boy. Correct. I assumed Rama is a bad boy, but I'm not able to prove that he is a bad boy. Then what he is? He is a good boy. Correct. What I assumed, my assumption is Rama. What I have to prove is I have to prove that Rama is a good boy. I assume my assumption is contrary. Contrary means ulta. I am assuming in the other way. I am assuming that Rama is a bad boy. So I did some proof. I did some like calculations for some simplification part. I'm just saying explaining in mathematical. So I did something. I am not able to prove that Rama is a bad boy. Then what Rama is? Rama is a good boy. So similarly, I hope I made you understood. Okay, before going to that, let us assume on contrary. These steps are very important. Let us assume on contrary. Contrary in the sense opposite to the statement. The statement is root 2 is irrational. But my assumption is opposite to that. Let us assume on contrary. Okay, let us assume on contrary that root 2 is rational. I assume that root 2 is a rational number. Actually, we have to prove that root 2 is an irrational number, but we are assuming root 2 as a rational number. Correct? So, yeah, whenever you consider a rational number, it should be written in P by Q form. Correct? Any number which can be written in P by Q form is called a rational number, and everybody knows that. So, I assume that let root 2 is equal to AB, and A and B are co-prime numbers. Co-prime number means they are prime numbers. I am assuming that root 2 is equal to AB, where A and B are co-prime numbers. Co-prime numbers in the sense they are the prime numbers. Just like what are prime numbers? Numbers which has one and itself as its factors, that is called a prime number. Correct? It means A and B has only 1 and itself as a factor. So they are prime numbers, we assume. Correct? So now next step, what I assume, what the next step is, just send this B this side. So which becomes b root 2 is equal to a. Correct? So which becomes b root 2 into a. Square on both the sides. Right? These steps are very important. Square on both sides. When you square on both the sides, it becomes b root 2 whole square, which is equal to a square. B root 2 whole square, which is equal to a square. And this square belongs to both the terms. So it will become b square into root 2 whole square, which is equal to a square. And root 2 whole square, root and square will get cancelled. You will be getting 2b square is equal to a square. Correct? This will become 2b square, which is equal to a square. Correct? Now you see, can I write b square is equal to a square by 2? Correct? You can send that to that side. So what I am telling here, just by using the theorem, why I explain the theorem because of this. So here b divides, correct? 2 divides it. 2 is dividing a square. No, can I write 2 divides a square? Because a square is dividing 2. Correct? Or you can write a square is divisible by 2. Or 2 divides a square. So 2 is dividing a square. If 2 divides a square, 2 divides a also, right? That is only the theorem I explained. 64 is divisible by a square in the sense 64 is divisible by 8 also. Similarly, if 2 divides a square, your 2 divides a also. Correct? Okay. You just, I hope you understood this. We proved that 2 divides a square. It means a can be written as 2 into c. Correct? It means a is also divisible by 2, right? If a square is divisible by 2, it means even a by 2 is also possible. Correct? So, if 2 divides a square, 2 divides a also, as from the, or you can write by the above theorem. By the above theorem, we proved that. Okay. Now, let me take one assumption again here. Let a is equal to 2c. What I am assuming? In the place of a, I am assuming 2c. So, what is, you just substitute the 2c, this you take it as equation 1 in equation 1. Let a is equal to 2c and use in equation 1. So, what you get? If you substitute 2b square is equal to, in the place of a, I am writing 2c. Guys, carefully listen. In the place of a, I am writing 2b square. In the place of a, I substituted 2c. So 2c square. So 2b square is equal to 2 square into c square. Correct? Which is nothing but 2b square is equal to 4c square and 2 ones are 2 2s are. We proved b square is equal to c square by 2. Correct? Or we can also say that, or you can write this is 2c square. Okay. Let me write in this way. It will become 2c square. Can I write b square by 2 is equal to c square? Correct? The 2 will come in the denominator. So b square by 2 is equal to c square. Same we got here. See, b square is equal to a square by d. Here c square is equal to b square by 2. Correct? Here, can I write 2 divides, okay, a square also? Yeah, we did the a square. Here, 2 divides b square also. Correct? See, b square is divisible by 2. So, can I write 2 divides b square also? As it divides a square, similarly it is dividing b square also. From the theorem, can I write 2 divides b also? As we said, 2 divides a square, so 2 divides c. Similarly, if 2 divides b square, 2 divides b also. Okay? So, you can write how we can say that by theorem above. Okay? Or we can write some 8.1, some theorem name is there, like this. Not especially there is a name for that. You have that section number 8.12 or something that you can write, or you can directly write by the theorem above what we discussed. So 2 divides b square and 2 divides b. So here you understand 2 is the common factor. Okay? 2 is the common factor for a and b. Correct? Correct. Here 2 divides a and 2 divides b. It means 2 is a is divisible by 2 also. B is also divisible by 2. So it means the common factor, right? This 2 is the common factor by for like A and B also. So what we assumed, A and B are co-prime numbers, means prime numbers. We assumed A and B are prime numbers. It means you should not get any factor apart from 1 and itself. But we are getting 2 as a common factor for both A and B. So our assumption is correct? No. So here 2 is the common factor for A and B. Our assumption, so we assumed that A and B are co-prime numbers. Okay, we assumed A and B are co-prime numbers because we should not get any factors apart from 1 and itself, but we are getting 2. So we assume that the A and B are co-prime numbers. Hence our assumption is wrong, correct? Hence our assumption is wrong. So we assumed whatever the assumption we did, that is wrong. Okay, hence our assumption is wrong. Therefore, okay, root 2 is irrational. We assumed it as rational. See guys, carefully listen. We assumed root 2 as rational, but we are not able to prove that root 2 as rational. So obviously root 2 is irrational. That is the reason I have given you an example. We assumed that Rama is a good boy. Sorry, we have to prove that Rama is a good boy. We assumed that Rama is a bad boy, but we are not able to prove that Rama is a bad boy. Everybody knows Rama is not, like the bad, correct? Rama is good. So that's the reason we will get the proof as incorrect. Or what is it? Assumption as incorrect. So what I assume, we assumed root 2 as rational, but we proved that root 2 is not rational. Here we are not able to prove. We are not getting any proof to prove that root 2 as rational. So if you are not unable to prove that it is rational, then obviously it is irrational. The proof is Rama is a good boy. We assume that Rama is a bad boy, and you are not able to prove that Rama is a bad boy. Then obviously Rama is a good boy, isn't it? So that's how you can remember this, and this is very, very important. So that's the reason I am stressing on this. Definitely, you will get one question based on the same concept. Okay. Yeah. Let me explain this once again. See, what we have to prove. We have to prove that root 2 is irrational. That is a proof. Correct. So what I am doing, let us assume on contrary that root 2 is rational. So I am assuming that root 2 as a rational number. Okay. And as we know that root 2, if any number is a rational number, any rational number can be written in the form of p by k. So that's the reason, like root 2 is equal to a by b. Instead of p and b, I have taken a by b. Any fraction format you can take, a and b. So where a and b are co-prime numbers, it means prime numbers. Just assume that they should be prime numbers. It means what? A and b should not have a common factor other than 1. That is the assumption we made. So what I did, I just sent this b that side, it became b root 2 is equal to a, squared on both the sides, we got b root 2 whole square is equal to a square. Take this 2 inside, it becomes b square into root 2 square, which is equal to a square. So which is b square, root 2 square is 2, so 2b square is equal to a square. So we can also write that you take as equation 1. So now what we assume, what we got, b square is equal to a square by 2 can be right, because 2 will go in the denominator here, and as from this theorem we can say that if p divides a square, obviously p divides a also. If 2 divides a square, 2 divides a also. Okay? If 2 divides a square, 2 divides a also. Similarly, okay, it means we got by the theorem above 2 divides a square, we can conclude that 2 divides a. Next assumption is, we assumed a is equal to 2c, and that assumption I am substituting in equation 1. So wherever a is there, you just substitute 2 into c. So substitute 2b square is equal to 2c whole square. So take the square inside, 2b square is equal to 2 square into c square. So 2b square is equal to 2 square is what? 4, right? 4c square. and this 2, actually you can divide 2 ones are 2 twos are. This 2 you send it to the LHS, so it becomes b square by c square. It means here we got 2 divides b square. See, 2 is dividing b square. If 2 divides b square from this theorem, 2 divides b also. Correct? If 2 divides b square, then obviously 2 divides b also. So by the theorem above, we can say 2 divides b. And what we got? We got 2 as the common factor for a and b also. But what we assumed that a and b are co-prime numbers. It means prime numbers should not have a common factor, should not have a factor other than 1 in itself. But we are getting 2 as a common factor for a and b. So what we are telling, we are just explaining that to you, that so that we assumed that a and b are common co-prime numbers. Okay, hence our assumption is wrong. So we assumed that they are co-prime numbers, but we are getting a common factor for both. Then definitely they are not a co-prime numbers. Correct? Because they have 2 as a common factor. This 2 is common factor for a also as well as for b also. That is the reason our assumption is incorrect, our assumption is wrong, so that root 2 is irrational. So we proved that root 2 as an irrational number. Okay, I hope I made you understood this. Okay, as for this, you just assume or you just remember the Rama's example. It is very easy to remember. Also, it will help you to help you to. I'm not telling that will help you to solve the sum. That will help you to remember the format, because this is a new kind of thing to you guys. These many days you might have not come across this kind of proof. Correct? This is a new proof to you. So that's the reason. If you assume that, if you remember that Rama is a good boy, correct? Our assumption is Rama is not a good boy. Means Rama is a bad boy, we assume, and we are not able to prove that Rama is a bad boy. Hence Rama is a good boy. That is only the process we followed in this. Okay. I hope I made you understood in this video. I hope you guys understood this. And as I'm telling you, this is very, very important topic. I'm stressing. Maybe I'm telling you second or third time for you guys. So focus on this topic. Okay. Thank you. Okay. Thank you guys, and please comment, like, share, and subscribe to our channel.